Do this, I guess. It looks like most of you guys have got this correct in the chat box. Good job. So I'm going to take my little -2 out here, and I'm going to distribute it and multiply it times my exponents in there, right? So I get a times -2 times -3/2 is just 3, right? Because the 2's cancel out, and a negative times a negative is a positive.
Wait, -2.
So, right. So it's -3/2 times -2 equals 6/2, which is 3.
Oh, because you're doing the exponents.
Yes, you're just multiplying the exponents.
Yeah, okay.
Okay? And then I'm going to multiply the exponents. The second exponent is 7/4 times -2, which is -14/4, or -7/2. So that's b to the -7/2. And it's a negative exponent, so I need to move because I'm only supposed to have positive exponents, right? So this is actually going to be a to the 3rd over b to the 7/2, which is great. It doesn't say I have to simplify. Oh, well, it does say simplify, so I can rewrite this also. This is a perfectly acceptable answer, but I can also write it as a to the 3rd over b to the 3rd square root of b, which I think is an uglier answer, right? I think the other one is a better answer, so I would just leave it this way. It didn't say anything about actually simplifying the exponent. It just says simplify the problem, so I did simplify the problem. So just going to say that.
So that's the answer.
Yeah, that's my answer. So I'm going to do the same thing on this one, as I'm going to distribute this through, right? So I have 3/2 times -1/2, which is x to the -3/4, y to the 1st, because -2 times -1/2 is 1. Okay? Which is going to equal y over x to the 3/4.
Wait, what did you say? -1/2 times what?
-1/2 times -2.
Oh, yeah.
Right here.
Is 1.
Is 1, yeah. So y to the 1st power. Oh, there's one of them here. One of the two of them made it to class.
Hey, TV Nia. Is that supposed to be a negative sign? By the Y?
You mean my little tail here?
No, on the other side of it.
No, it's an equal sign.
Okay, that's what I thought.
Sorry. Oh, okay. Questions? Are we good?
Yeah.
Awesome sauce. Okay. So now we're going to move on to today's lesson, which is multiplying. Basically, we're going to multiply radical expressions. And a radical, oh, yeah, here she is. She made it.
Isn't he out here?
Yeah, she's online.
Don't say anything to me else here when you come late like that.
Yeah, shut up.
Crazy that you guys both showed up at the exact same time though.
Do you need notes for today?
Yes, please.
Okay.
She's gonna print them.
I'm going to print them out.
So where were you, Eva?
Spoiling the world.
And why were you wandering the hallways and getting pictures taken of you?
Yeah, Eva, where were you?
Yeah, shut up. I don't even have a first or second, so I don't know where to go. So like.
Hi,
The
Eva.
library.
No, you can't
Hi,
go.
Shanae.
Oh, I think
Can I get there?
You said where? The library?
I don't think you can go to the library anymore.
I know. I was like.
Hi,
If you don't have
McKenna.
class,
Uh,
so,
So-
do you take bus to school?
Hi, Jenny. Jenny, do you want notes too? Okay. Oh, yeah.
She has her iPad.
Yeah, I remembered. As soon as I asked her, I remembered that she has her iPad.
So where did you just come from? Outside? Downstairs?
somewhere out there.
I want to know.
So do your sister and brother not have a first and second period either?
No, I have to walk them to class because they're kind of slow.
Oh, is that what you're doing on the floor?
Yeah.
When I saw you, I was like, I just saw you guys down there.
Okay, so we're gonna multiply square roots and nth roots together today. That's what we're doing. So we're multiplying stuff together. So it says, the rule says for any real numbers, the nth root of A and the nth root of B, the nth root of A times the nth root of B is the nth root of A times B. Notice that, I'm gonna make this a little bigger so you guys in here can see it, that the roots have to be the same before I multiply them together. This has to be the same. So I can't multiply like a square root and a cubed root together, what's inside. The nth roots have to be the same, and then I can multiply what's underneath together. Okay? If they're not the same, I can't do that. Are we all right with that?
Can you get them to be the same?
No. So that's a difficult question. So if what's inside the square root or the root is the same, then I can rewrite it as an exponent, right? And then I can, then the bases are the same and I can add the exponents together. I can do it that way. But if what's inside the exponent, the root is not the same, no.
Okay. So there is a way.
There is a way in specific circumstances. Okay?
Will that ever happen?
No.
Okay.
No.
So
All the ones we're going to do will have the same root.
So I don't gotta
Okay?
worry about
Yeah, you're not going to have to worry about it. Okay. So, so for the first one, it's pretty easy, right? I've got the same root. I've got a fourth root and a fourth root, which means I can rewrite this as the fourth root of 4 times 10, which is the fourth root of 40. And I can't simplify that because there's not 4 of the same number that multiplied together that equal 40.
So then that,
Oh, yeah, of course, McKenna. Sorry, I just saw that.
Wait, what was it? Campbell, which question are we on?
look at
Number 1.
Oh, okay.
Wait, what has to be the same? The square root?
The root, whatever root. So if it's a fourth root or a cubed root or whatever the nth power, whatever root it is, has to be the same. Okay?
Okay.
All right. So on the second one, they're both, oh, shoot. Sorry. What the heck? Okay, that was weird. Okay. My iPad's going crazy. So they're both the fifth roots here. So that means I can take what's in the inside and I can multiply them together. So I have the fifth root of 9t squared times 2t, which is going to be the fifth root of 18t cubed. Done.
Okay.
Questions? I can make that bigger if you need me to. I can go about there. Is that better?
Yeah.
Okay. Because I know you can't see anything.
Yeah, thanks.
You're welcome. Okay.
You add the t's together?
Yeah, if it's the same base, which is the t, then I just add the exponent. So that means I have t squared, which is 2 t's, and then 1 t gives me t cubed. 3 t's together. Did that help? Did that answer your question? Okay. All right, then if I go to number 3, again, they're both a fourth root here. So that means I can multiply what's on the inside together. This one's going to be a little more difficult. So I have a fourth root of x minus 1 times x squared plus x plus 1. So I need to multiply that all together. Beautiful. So,
Why would you do that to yourself?
yeah, well, you know, because I can, I don't know. So I've got x minus 1, x squared, x, and 1. So this is x cubed. X times x is x squared. X times 1 is x. X squared times negative 1 is negative x squared. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. My like terms are on the diagonal. So looks like those equal 0, right? So that means I have the fourth root of x cubed minus 1. Yeah. Okay. Oh, lunch is over. I'm almost getting used to the lunch bells now. Almost.
So why weren't you used to it
Miss
before?
Campbell,
Yeah, honey?
I'm gonna leave and then I'm gonna be there for.
Oh, okay, Emma, not a problem. Okay, everyone okay?
No.
Okay. We already knew that, by the way.
Well, some people didn't, so.
Are you sure?
Yeah, I hope so.
Okay. Notice I whispered so they couldn't hear me.
You whisper pretty loud. It's like me trying to whisper.
It's because I'm trying to whisper through the mask.
Oh, yeah. You know, wait, why weren't you here last time?
Monday?
Yeah.
I think I got food poisoning over the weekend on Friday,
That's sad.
so I was pretty sick all weekend. And I pretty much slept all day Monday.
Sounds nice, though.
Except that then I didn't sleep Monday night.
Doesn't sound as nice.
No, I know, right? So 4:45 came really early in the morning.
4:45.
That's what time my alarm clock goes off. Okay, you guys have 6 problems, A through F. So go ahead and work on those. I will always tell everyone that when they say otherwise about you.
What?
Okay. So all of these, the roots are the same. So this is going to be the cubed root of 35. And then we've got the fourth root of 54. And then the square root of 26xy. If you guys need help on any of these, let me know, please. The fifth root of 80y to the fourth. Woo! And then E is the square root of 6s divided by 11t. And then F should be the seventh root of, let's see, that would be 5x minus 15 divided by 4x plus 8. Do you have a question on that?
Yeah, why is it 5x and 4x?
Okay, well, I take 5 and I distribute it through. And then I take 4 and I distribute that through. Right, because this is 5 times x minus 3 over 4 times x plus 2, the seventh root of that. Is that okay? Does that make sense?
Yeah.
Okay. Any other questions, anybody? Nice
Only
job.
2 pages?
Yeah, it's only 2 pages today.
Oh, that's amazing.
We're gonna be done quick. I know. It was only 1 page, just so you know, last year, because then part of the homework from last year is in here, and then you have your homework online. I know. Since we had to change things up. Okay, so now we're gonna simplify again. So I need to simplify the square root of 300. So now I need to think about what numbers go into 300. I really want a perfect square. Does anyone know what a perfect square is?
No.
Perfect square is a number that when I multiply it two of the same numbers together, I get it. Like 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. So my perfect squares, so I'll write them out. Perfect square would be like 4, well, 1's my first one, because 1 times 1, right? And then 4, 9, 16, 25, 36, 49, 64, that's 8, right?
Yeah.
So then it would be 81, 100,
And
121, 144, 169, 196, 225, 280. I want to say 289. I always forget 16 times 16. I think it's 289, but it doesn't matter. You probably won't get up there. But I want to look for one of those numbers, okay? So what times what is 300? Well, I know
150.
that 3 times 100 is 300, correct? You guys okay with that?
Oh, what
Okay.
times itself?
What equals, what times? Yes, not what times itself. What times what is 300, okay? And using that, I know that 100, if I look at this, right, I already know that 100 is a perfect square. Yeah? Are we okay with that?
Yep.
So now, using the rule that we learned, I can go in reverse also, right? So I can also, it was times, so now I could also write this as the square root of 100 times the square root of 3. I can write it as 2 separate ones. Not only can I put them together, I can also separate them out. Does that make sense? So then I can say, well, what's the square root of 100? 10. So this becomes 10 square root of 3. Usually, I'm just going to say this, we don't do the middle step, right? Usually I don't do the middle step, but I like writing that. Some people need to see it because they need to see, oh, I can separate that out. Usually I say, oh, here's the square root of 100. I can bring a 10 out, right? So if you can do that, you don't need to have that middle step.
Okay, hold up before you move on.
Okay, I'm holding up.
Thanks, you're the best.
I try. Have a drink of water while you're. And is your hair getting darker?
Me?
Yeah.
Possibly? I don't know.
Are you done now?
Yeah, wait, I just don't know how you got from 100 from the second part to the third part.
What's the square root of 100?
10. Oh, that's it?
Yeah,
Okay.
that's it.
Okay.
Okay. So now we're going to go to the second one. I'm going to do the same thing, right? It's the square root of 175 y to the 8th. Only now I've involved a variable, yeah, and an exponent. Thank you. So I need to know what times what is 175. And again, I want to look at my perfect squares. I'll try and get them up on the board for you guys. So which one of those go into 175? Which one of my perfect squares go into 175? Well, I know a quarter does, right? 25 does. How many quarters are in $1.75?
7.
Yes, good, 7. So I know that this, I can rewrite this as 25 times 7 times y to the 8th, right? Okay, so then according to my rule, I can rewrite this again as the square root of 25 times the square root of y to the 8th. And yeah, I moved that up. I know I did. I'm so sorry. I just, doesn't matter what order you multiply things in. No, so I can rearrange stuff. And I rearranged it because I know how many y's are inside my square root.
Wait, what?
How many y's are inside my square root?
1, 8.
8, right? And I have 8 in there. And I need groups of how many? I'm trying to make groups of how many? 2, because it's a square root.
Yeah.
So how many groups of 2 do I have?
3, 4.
4, right? Because I have 8, so I have 4 groups of 2. That means when I bring it out, the square root of y to the 8th is y to the 4th. So the square root of 25 is 5. The square root of y to the 8th is y to the 4th. And then the square root of 7, because 1 times 7 is 7, so you can't do anything with that.
Okay.
Are you okay with that? Emma, are you okay?
Just spaced out.
Okay.
Kind of. I don't know where.
With the variable or with the numbers?
See, that's the thing. I don't know where I'm getting lost.
Could you explain the 5y to the 4? That's where
Okay, so are you okay with this step here?
Yeah.
And where I found everything. So what's the square root? So I just went through each of the 3 square roots and simplified it. So the square root of 25 is 5. Are you okay with that? Okay, so the square root of y to the 8th. So remember, a square root means I have to have 2 of the same thing before I bring one thing out, right? So if I have 8 y's inside my square root, how many sets of 2 do I need to bring? That's not how I want to say it. I need a group of 2. So let's do it this way. So I have 8 in there, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. But so I need groups of 2 to bring it outside my square root. So to bring 1 out, I need 2 inside. So I can bring 1 out, 2 out, 3 out, 4 out. That gives me y to the 4th. Does that help? That visual help a little bit more?
No, I understood that part.
Okay. And then I can't do anything with the 7 because the only thing that multiplies to be 7 is 1 and 7. Those 2 aren't the same thing.
Oh, so when you break it down, the square root goes away because that's what the square root is.
Right, because in order to bring something outside of a square root, I need to have 2 of the same thing. So if I look at 25, right, the square root of 25, that's the square root of 5 times 5. So I have 2 5s inside, so I can bring 1 5 out.
Okay, that's where I was getting lost.
Is that okay? Was it just the definition of what square root is?
Yeah.
Yeah.
It was just when the square root went away, I was like, where did it go?
Yeah, so if I have, that's what the definition of square root means. If I have 2 of the same thing inside, I can bring 1 out and the square root's gone. Okay, so a cubed root would mean if I have 3 of the same thing inside, I can bring 1 thing out.
Okay.
Okay?
Makes sense. Thank you.
You're welcome. Okay, speaking of cubed roots, now we have a cube root, right? So, and I have negative 32. This one I need to, we're going to, how do I want to do this? How do I want to talk about this? I think what I'm going to do here is I'm going to do a factor tree. Is that okay with you guys? Because, yeah, do you remember those in like elementary school?
What do they look like?
A tree.
Yeah, basically, right? And they start yeah. So I've got negative 32, right? What goes into negative 32? How about 2? It's got an even number, right, at the end?
Oh, this?
Yeah, factor tree. And so 2 goes into 32 16 times. Sorry, the iPad went a little crazy for a second. Okay. 16. So I'm going to ignore the negative sign just for a minute, okay? It's not going to affect my factor tree for a second. Are you guys okay with that? Okay. So what goes into 16? 2 again, and 2 goes into 16 8 times, and then 2 goes into 8 4 times. Oh, and then look, I can keep going, right? I can. But I just need 3 of the same thing. So if I factor more, am I going to get another set of 3 is my question.
No.
4 is just 2 times 2. So I'm not. I'm done. Is that okay with you guys?
Yes.
Okay. So the other thing I need to talk about is this negative sign. I really don't want a negative inside my root sign. So what's a negative times a negative times a negative?
A negative.
Yeah. So what if I said these 2's are all negatives? So then I have 3 negative 2s. I have 3 of the same number. Are we okay?
Yeah.
So I'm going to break this down to be, let's see, how can I write this so it makes sense? The cubed root of negative 2 times negative 2 times negative 2 times 4 times g to the 6th. Okay? So now I have 3, let's see.
Wait, what?
What do you mean what? Go ahead, ask. I just took my factors, negative 2 times negative 2 times negative 2 times 4. That's negative 32.
Why is 4 in there?
Because it's right here. It's part of my factor tree. Negative 2 times negative 2 times negative 2 is only negative 8. And it needs to equal 32. Still needs to be this number here, which is 32, correct? Okay. So now I have 3 negative 2's inside my cubed root, so I can bring 1 negative 2 out. So I have a negative 2 on the outside. How many g's do I have inside?
6,
And what am I making groups of this time?
3,
3. So how many groups of 3 do I have?
2,
2. So I can bring how many g's outside?
1. Huh?
How many can I bring outside?
1, 2.
2, because I have 2 groups of 3,
Oh yeah.
right? And then what's left inside? My cubed root,
The 4 in
the 4, and that's it. Okay, so when it starts getting a little harder, you just have to take little pieces at a time, okay? And then just pull them out and leave what's inside. I hope that kind of helps out a little bit, but we'll see as you guys do some of these practice. Yeah, practice, and then we'll go over them again. Okay, so. Hello? Can you hold on just 1 second? Thanks. Thanks for helping me out. Okay. Oh, that's so fine. That works out great, actually, Zach. I like that you put that.
Of course it's Zach.
No, he's telling me how he didn't know how to do a square root, so he put the 2 divide signs together like this for a square root.
Divide signs?
Yeah, you know the slash sign for divide?
Slash.
Yeah, slash sign, whatever. I don't know what they're called. Don't make fun of
You're
me.
not that old. You should know what it's called.
Oh, honey. I learned how to type on a typewriter, not a computer.
I want to say something, but let's not go there.
An electric typewriter, not a computer. Please, I'm that old. Okay, so 8 is 4 times 2. And this is x. Be quiet. Be quiet. So the square root of 4 is 2. Yeah, good. Is 2. And then I want to talk about my, so this part is gone. My 4 is gone, right? Now I want to talk about my x to the 9th. I have x to the 9th. I have 9 x's in there. How many groups of 2 can I make?
4.
4. So I can bring an x to the 4th out. How many x's did I use to make the 4 groups of 2?
8.
So how many x's are left inside the square root?
1.
Very good. So that's the square root of 2x.
Wait, why is it 42?
Where's a 42?
Where's the 4 and the 2? Where did that come from?
8 is 4 times 2.
Okay, see?
See the little dot in between them?
No, but it's okay. I understand where it's...
See the little dot in between them?
I see it now. Okay,
Okay.
Hi.
Sorry.
Did you just add that dot?
No, honey, I didn't. It was
Okay,
been
I
there.
didn't see it either.
Oh, yeah, it's 4 times 2.
See? I knew I wasn't the only one.
I thought you wrote 42, and then I was gonna say something, but then I'm probably wrong.
No, I just blew it up. That makes it a little easier. Okay, so what goes into 350? Well, I know 25 does. How many times does 25 go into $3.50?
10? No.
14.
Yeah.
14?
Yes.
Yeah, 14. Good. Times 14. And 14 is 2 times 7, right? So huh?
Yeah.
Are you counting again?
No, yeah, I was like.
4
what
times
did
3
you
is
say?
12, plus 2 is 14.
No, yeah, but I was just wondering what I said. But it doesn't matter.
I don't remember what you said.
Neither do I, so it's okay.
Okay. So the square root of 25 is 5.
Yeah. What?
Square root of 14. Is it a little easier to see my dot when I make it bigger? Okay.
And that's the answer?
That's it, because 14 is 2 times 7, so is there 2 of the same numbers in 14?
No, there's not.
There is not. Good. Very, very good. Come on, slide over. Okay, now we got 75. What goes into 75?
5.
What do my perfect squares go in there? 25.
25.
25. And how many quarters are in 75 cents?
3.
3 times y to the 5th. So what's the square root of 25?
5.
5. How many sets of 2 y's can I bring out?
2.
2. Great. So what's left inside my square root? Well, I've got a 3 as a number. And how many y's are left inside? 1. Because I used 4 of them to bring 2 out, right? Okay, very good.
Wait, so is what you're trying to do is just have nothing in the square?
Yeah, yep. It's the least amount I can have left inside the square root.
Okay.
Yep.
That makes a lot more sense.
Good. Okay, so let's try D. Woo! All right. So how many A's can I bring out?
5.
5. And how many B's can I bring out?
5.
Beautiful. And how many A's are left inside?
None.
And how many B's are left inside?
1.
Nice job.
Thanks.
You're welcome. They're like, I'm getting it. I understand now. Right? Not too bad? Yeah. Variables are pretty easy. Okay. E. How many X's am I bringing out? What is my root?
3.
3. So how many do I have to have?
You're gonna bring
Oh,
one.
so now I'm changed. I'm not a square root this time. Next time I have to have 3 inside to bring 1 out. So I can bring 1 X out. How many Y's can I bring out?
2.
2. How many Z's can I bring out?
3.
3. Beautiful. And then how many X's are left inside?
2.
How many Y's are left inside? And how many Z's are left inside?
1.
1. Beautiful.
That's it?
Yeah, that's it.
Oh, okay.
I know.
I didn't realize how easy it was
Until we went to variables. You should have started off.
Numbers
with
are a little harder just because they're not factored already, whereas these variables are already factored, right? So if you can take the number and factor it and write it like this, then it's just as easy. Okay? So now we're going to add a number in, but look what my root is. It's a 4th root. So this one means I have to have 4 things inside to bring 1 out.
Yes.
Okay? Whatever this tells me, whatever this says, this is how many things I have to have inside to bring 1 out. Okay? So 16, so I'm going to do a little factor tree. I need 4 of the same thing. So what goes into 16? 4 and 4. But that's not 4 things. That's only 2.
Yeah.
So what goes into 4?
2.
And,
2.
right? So how many 2's do I have?
4.
4 2's. So what's the 4th root of 16? 2. So I can bring a 2 out. Great. How many X's can I bring out?
1.
1. How many Y's can I bring out? 2. Yep, good. And then I have the 4th root of, is there any numbers left?
No, there's only
Good. And how many x's are left?
1.
And how many y's are left? Yeah, good, Rukia. You said 3, right? Oh, Hiva said it? Sorry. I know it was one of the girls over here. Tavinia, you're being quiet today.
Yeah. Oh, shouldn't typo. Shouldn't typo with your name. I just know it, huh, Hiva? Yep.
I have a feeling.
I don't doubt it.
So the last section, we're going to combine the last 2 things we did. We're going to multiply it, and then we're going to simplify it. So when we multiply it, like the first time when we multiplied them together, it didn't give us anything to simplify, so they stayed underneath whatever the root was. This time it's going to be bigger, so I can simplify it down.
Okay.
Does that make sense?
Yeah, why do people do this? Why?
Engineering stuff.
Okay.
I know.
That makes more sense. Okay.
I mean, someday you guys might be in college and be like, this math really kind of is cool, and like maybe I want to be an engineer,
Maybe.
make lots of money.
Yeah. Seems like a lot of work, but. Anyways, go on.
Yeah, but the more you can make lots of money.
Yeah. It's okay. I can find money.
I was going to do that one time, once upon a time.
Then what happened?
Yeah, I decided I like teaching.
Oh,
I know.
okay. That's not what
I like you guys, but you know, it's just like, well, first I was going to do engineering, then I changed to law. I was going to become a lawyer. Can you guys believe that? That would have been really scary.
Yeah.
Besides, then you had to do all this language arts stuff, and I was like, I don't think I can do that. So that was gone. And and then by the time I was a senior, I'm like, yep, I'm going to be a teacher. And I was like, I don't want to go. I need to take some time off before I go back and get all my teaching certificates, everything you need for that. So 15 years later, I went back and got my teaching credentials. So now I'm a teacher.
15 years later.
Yeah, I was going to only take a year or 2 off, 15 years later. You know, life happens. So don't take too much time off when you go to college if you change your majors a lot. Don't do that.
Okay.
That's some advice from the old broad in the classroom.
I swear you're still joking.
I am not joking. Okay. That's why they laugh at me when I'm trying to coach volleyball and I can't move. I'm like, I'm 53 years old. I can't do the things you guys can do.
Does she look 53? That's what I was saying. That's why I don't believe her.
Okay, so let's multiply this together. The roots are the same, so that means I can just multiply the inside together. So I get the cubed root of 7 times 3 is 21x cubed. So to simplify that, I can't simplify the number because that's 7 times 3. Those aren't the same thing. But can I bring the x out?
Yeah.
How many x's can I bring out?
All of them.
1. Great.
Now what?
So I can bring 1 x out. Are there any x's left inside?
No.
Nope. There you go. Because there was 3 inside, so I brought 1 out. Done.
Because you guys have groups of 3.
Yep. Nice job. Hey, you guys might be able to start coming to school every day now.
When?
Soon.
When?
Huh?
When?
Soon.
How soon?
When is it?
Yeah, that's.
I'm thinking, this is just me thinking, within 2 weeks.
Like everyone?
Yeah. You can choose to stay online though. They don't have to come into school. But like, if you guys want to come on your non-days, you can come then too.
How many people do you have tomorrow?
During this class, less than this.
Nice.
Yeah.
Yeah, it's like your biggest class.
Yeah.
And then Tua comes every so often.
He came 1 time.
He came twice.
No, he came once.
No, he came twice.
It was definitely twice.
Was it twice?
Yeah, it was definitely
Oh.
twice.
Tua, you came twice? He's not on here now.
Yeah, I did.
Yeah, so yeah, you guys will be able to come pretty soon. So there'll still be less than 20 kids in here. I mean, there might be a little more than 10. You might actually have someone on the other side of your shield.
Hi.
The other side of your shield.
That was so weird.
Would we still
I think I'm just like the detail.
I'm sorry, what, Emma?
Would we still have asynchronous Wednesdays?
Asynchronous days on Wednesday.
Oh, yeah. Yes. Because that's the day they, the custodian crew goes and like super deep cleans. So they do that. So it'll still be asynchronous days. At least that's what I've heard so far. So, but as soon as I know for sure, I'll let you guys know. I'll be kind of happy because like last class, I had 0 students.
0?
0. And my next class, I may have 3, but they're juniors and it's after lunch, so I think they just go home now. And just do, right? I mean, it's the last class of the day, it's after lunch. Just go home. So I don't know. Okay, so number 2. I know, you guys don't like me anymore.
No, I mean after lunch. I wish I could just go home.
Me too.
I could probably try to.
I will soon. I have fourth period prep next quarter.
Oh yeah.
Yeah.
Is that the best?
Yeah, I like fourth period prep.
When do you have prep this quarter?
First period.
At least do you ever get to come in late because you have prep?
No,
Why?
because I'm always getting ready for the day.
Anyways.
So how many X's can I bring out?
1.
How many Y's can I bring out? 3. Good. And I have the cubed root. How many X's are left inside? How many Y's are left inside? 1. That was easy. That was easy peasy.
Yeah, but it looks hard.
Squeezy.
Easy peasy squeezy.
I don't know. Yeah, easy peasy squeezy.
That doesn't sound right.
I know it. Steven had a great game last night.
Steven? Yeah, you see how tall he is?
And he's in AP Calc.
Yeah, he better be.
Steven is so smart.
No, I'm just saying. I hated having class with him sometimes.
Every single math class I saw next to Steven.
Yeah. This is the
Did
only
you
class-
copy off of him, McKenna?
No!
Don't lie.
Look,
It's okay.
look, her voice goes up. No, of course not.
Look, it's still up. It's okay if you did.
No, I actually don't remember doing that, but
I'm just kidding, McKenna.
like we definitely switched seats a lot, but I remember sitting next to him like the whole
Do you guys have Mr. Call?
We had our freshman year we had this girl.
Oh, just for freshman year?
Yeah.
Oh, I thought you meant every year. And I was like, oh my gosh. I had class with him that much.
But then my freshman year we had every single class together.